Welcome, students. In this short video, we are going to study how to calculate limits. We will take a look at a quick rundown of some basic properties of limits, which later on we are going to use in our next video, where we will solve a bunch of problems involving limits. So let's start. First theorem here. If k is a constant, then limit as x approaches to a of k is equal to k. Limit of x as x is approaching to a is a. Limit one-sided, left-sided limit of 1 over x as x is approaching to 0 from left side is equal to minus infinity. Same limit as x is approaching to 0 from right side is plus infinity. Then you can confirm this by quickly graphing your functions here. Next, here we have a bunch of properties for limits. First of all, let a be a constant, and we'll assume that two-sided limit of f of x when x is approaching to a exists and equal to L1, and limit as x approaches to a of g of x is equal to L2. Then we have following 5 properties. Limit of a sum can be expressed as a sum of limits. So this limit of the sum of these two functions here is equal to L1 plus L2. Same works for limit of difference of two functions, which is equal to L1 minus L2 then. And if we have limit of a product of f of x and g of x, then this is equal to L1 multiplied by L2. So limit of a product is equal to the product of limits. Limit of a ratio of these two functions is equal to the ratio of limits and is equal to L1 over L2 as long as L2 is not equal to 0. And a limit of nth root of f of x is equal to nth root of limit of f of x and is equal to nth root of L1, assuming that L1 is positive when n is even. And obviously, these all are going to work well for one-sided limits if they work for two-sided limits. Next property is for polynomials. Limit of polynomial p of x is simply equal to the value as x approaches to a is simply equal to the value of polynomial at point a for any real number a. Now, let's assume that f of x is defined as a fraction of p of x over q of x. So f of x is a rational function, and let a be any real number. If our denominator is non-zero, then limit as x is approaching to a of f of x is equal to f of a. And if a denominator is 0, but numerator is non-zero, then limit as x approaches to a of f of x doesn't exist. So that will sum up our properties for limits. In the next video now, we are going to use this to solve some problems.